Today we are working on 8.2. Let's do this one. Huh? All right. So 8.2 is going to talk about transformations. So we have several types of transformations that we're going to be dealing with. The easiest is a translation. A translation means, oops, doesn't mean that. A translation means you drag it up and down or left and right. And you can accomplish any movement you want with those two directions. How far up or down did we move it? How far left or right? That's called a translation. Okay. It's gonna let me. So we can have a reflection. A reflection means that we flip it either left and right or up and down. But in geometry, we actually do reflections across a line. So if this was, say, the y-axis, well, let's draw it out. To reflect that across the y-axis, it would end up looking like this. So not only would it change orientation, but it's going to move. So imagine that you folded a piece of paper along the y-axis and you flipped it over, and when the ink hit the other side, it drew a new figure. So this would no longer exist. It would move to the other side. Or we could flip it across the x-axis, and that would be upside down, and it also moved. So a reflection changes both the position and the orientation. What if it looked like that? What would flipping it across the y-axis do? It would look like that. So it didn't move a lot, but the orientation is different. Okay. And then yesterday we talked about dilations, and dilations change the size, right? And a dilation is based off of a point. Let's see. That's all of them. All right, so let's go in here. Oh no, I need this. Those of you at home watching the video don't know what I just did. All right, so all of those transformations are going to preserve the basic shape of the figure. It might get bigger or smaller, it might move around, it might change its orientation. Oh, we didn't talk about rotation. Rotation would be we spin it along a point. But every one of those four transformations is going to preserve the basic shape. It might change size, but every future version is going to be similar to the original version. The angles and the side ratios are going to be the same. So in this case, could we take the solid triangle and perform a series of transformations to turn it into the dashed triangle? Yes. So what would we need to do? So we're going to need to reflect it. So let's, which way? Left, right, or up, down? Left, right. So we flip it. Okay. Now what do I need to do to make it a different size? Dilate it. So we push the dilate button. I don't know how the dilate button works. Dilate. Oh, I unclicked it. Sorry. I might need a mouse to do it. It's not letting me do it from here. Hang on. All right. Oh, yeah, just move your mouse. Anyway, okay. What about this one? Let's try rotation. Oh, this is the one I want to rotate. So I click it, rotate it, click it, dilate it. There we go. Okay. Didn't I do it? Oh, good. It's not possible. Why? It's the wrong shape. Good eye. I didn't realize that. How did I ever graduate from college? I graduated 3 different times. All right. So here we have the solid shape. We want to turn figure A into this solid shape here. How are we going to do that? So which sequence of transformations will map A onto B? So translate A to the left 10 units and then dilate the result. So if I slid this left 10 and then did a dilation from the center, is it going to end up looking like this? No. Okay. Reflect A over the y-axis and then dilate 1/2 with respect to the origin. So if I flip this over and then I dilate by 1/2, which means it's going to get half as far from the origin, is that going to turn this shape into that shape? No. Okay. Rotate the figure counterclockwise 180 degrees about the origin and then scale it by 1/2. So if I took this and I rotated it 180 degrees, so that would be 90, 180, and then cut it in half, would it end up looking like that? Yes. So this point, 2, -2, is going to rotate, and it's going to be 2, -2, or it's going to be -2, 2. Cut that in half, and it turns into -1, 1. So yeah, it's going to be this one. Are A and B similar? Oh, did I miss it? Thank you. Oh, looks like. Oh, so is there only one way to turn this into that? No, we could reflect this way and then reflect this way and then dilate. So you're going to have to read all of them and make sure that all of them work. So if we dilated it to begin with and then we translated it left 4 units, is it going to match that one? No. So are A and B similar? Yes. Okay, that's it. 482. Get to work.